Algebras, and welcome to the Chapter 2, Lesson 1 notes. But before I get into Chapter 2, Lesson 1, I just want to do an overview of Chapter 2 in general, which is looking at univariate data, one variable data, so analyzing it, looking at plots, learning how to create the plots, learning how to use the graphing calculator for this. So you are going to need to have a graphing calculator tomorrow for the lesson 2, the lesson 3, the lesson 4. You're going to need your graphing calculator for the rest of these videos. Okay, so you'll notice that I have one on my screen right here. This is my TI emulator. This is an 84 plus. This is also an 84 plus. If you have a Chromebook, you have that free app available to you, and I link to that in every single one of my Google slideshows. So look for the green colored calculator to link for that. Chapter 2 is in the orange colored packet, so it looks just like this. As we know, I don't write on colored paper, I write on the white paper, but I'm showing you the orange packet as our overview, right? So today we're going to talk about interpreting distributions and their shapes. So we're just going to look at pictures. What are pictures of the distributions? And they're going to be the three main ones that we're going to learn how to create in Chapter 2. So we're going to be looking at dot plots, box plots, and histograms. So that's what we're going to learn how to make ourselves. Today, we're just going to talk about interpreting those pictures, those data, okay? Then we will get into measures of center. That's mean, median, mode, range. You've probably heard those words before, but those are our measures of center. We're going to learn how to kind of analyze those as well and how to find those on our graphing calculator, or most of those. We're going to create dot plots, which you will enjoy because of the ease of creating a dot plot. Then we're going to talk about deviations from the mean, which will include what standard deviation is and how to find it. Again, using our graphing calculator. So we're going to need that graphing calculator for a lot of this stuff. Then we have a review, and our quiz will be in Delta Math. Then the second half of the chapter, of course, creating box plots. Those are really fun. You will need a straight edge for those. And your graphing calculator, of course. Then calculating outliers. We're going to use some of our box plot data for that. Then we're going to create histograms. We do have an extra data review. We will probably not do it, but it's in there, and I will have the answer key for it. And then, of course, we have the exam review, and the Chapter 2 exam will be through Delta Math, just like we've had so far. All right, so here we go. I'm going to do this on my white paper. All right, so it's a little bit easier and then scans a little bit better. So let's talk about distributions and their shapes. So let's figure out what each of these is first. Okay, so we've got dot plots, which is for each and every data value, there is a dot indicating that piece of data. So this will be like a long number line, and every single dot on there is one piece of data from whatever study it was. Okay, and that scale, notice the scale has to be the same throughout. So you can't decide, oh, I have a lot of data pieces here to here, so each of these gets one, but each of these doesn't. You can't just change the scale. If your scale always went by twos, your whole scale goes by twos. If your scale always went by ones, the whole scale always goes by ones. If it went by fives, everything goes by fives. Okay, you can't change the scale midway. Then we've got histograms, and this is, a lot of people call this a bar graph. This is not a bar graph. This is called a histogram. And a histogram does use bars as intervals that are full of data. So each of these intervals has within it this much data. So this is your frequency. This is the actual interval from here to here. Now, all bars in the intervals are always the same width. All intervals have the same number of possible data values in them. So, for example, this one has 0, 1, 2, 3, 4, 5 pieces of data in it. The next one has 5, 6, 7, 8, 9, 5 pieces of data in it. Then it starts again at 10, 11, 12, 13, 14, 5 pieces of data potentially in it. And so that's why the bars are always exactly the same width. And that's what's different. It's a little bit different about a histogram versus what an actual bar graph is. And then, of course, last but not least, are box plots, which I like personally as the best because they are the easiest and quickest to make. But they also, because they're the easiest and quickest to make, show us just a quick snapshot of the data. The box plot divides all your data into 25% intervals or quarters. So each of the sections of the box plot is 25% of your data. So 1, 2, 3, 4 sections in your box plot. The middle, the box, is 50% of your data right in there. So you get a snapshot that 50% of your data is between here and here, and you get that snapshot right off the bat. That's what's great about a box plot. Okay, real quick visual to describe what's going on with your data. Alrighty, let's get into it and talk first about our dot plot. Now you'll note that these are just questions about interpreting the dot plot. So what I want you to do right now is I want you to stop and pause, and I want you to just look at the dot plot for 1 whole minute. Think about what you're learning from it. Think about what you're processing from it. Think about what it's saying. And then we'll answer the questions. So you should pause it here. Think about what it's saying. Okay. Okay, hopefully you're back. What do you think this graph is telling us about the flight delays for these 60 flights? Okay. Well, we know that we've got a dot plot of the delay times for 60 Big Air flights. So Big Air is the name of the airline. This is in December of 2012. So this is what our dot plot looks like. Where are you seeing the most data visually? Well, you're seeing a lot of delays right in here. The most delays are right in here. So what would you like to say about what do you think the graph is telling us? Okay. First of all, out of these 60 flights, how many were not delayed at all? 2. Every other flight was delayed in some fashion. So out of these 60 flights, almost every single one of them is delayed. Ain't great. But the majority are delayed between 10 and 40 minutes. Okay, look at that. Look at how many are delayed between there. That's a pretty good amount. Okay, out of those 60. All right, so what do you think this graph is telling us about the flight delays for these 60 flights? Sorry. There we go. We'll go this direction, right? The majority fall between 10 to 40 minutes. There you go. Can you think of a reason why this data would be presented? Normally, I would ask out for this, like talk, have a nice discussion, right? Who might be interested in this? Okay, so we've got a couple of people who might be interested in this, and you can, write your sentence as to how you feel about this. But I'm interested in it as a consumer, as someone who might book a Big Air flight. I want to know if I need to plan on a delay for sure or not. And if I'm booking a Big Air flight, I can pretty much guarantee I'm not going to be on an on-time flight. That flight is going to be delayed somehow, right? Who else might want to see this? Well, what about the pilots and the stewardesses and their families? And they want to know, stewardesses, both, right? They want to know, do we plan on having you back from work at the time you say, or are you going to be delayed? The CEO, this one always gets the CEO. I want to know, are my employees actually doing the right thing here? Are they getting those airline flights off? Are they helping? Where's the issue? Is it baggage? Is it at the ticket line? Is it at the gate? Like where's there this issue? Why are only 2 flights out on time? And also as the consumer, who's picking me up, right? Or am I Ubering home because I'm so late? When I come back, no one's there to pick me up, right? So planning for once you land too. So if you're already delayed, now the delay on the other end is going to be there too. And so how to leave the airport, how to go to where I need to go. I probably, if I'm going on a vacation, shouldn't make plans within 2 hours of my flight when I land, because it's possible that I could be delayed that long. All right. Not as probable, right? It's not as likely because there are only 2 delays that were 2 hours out of all these delays. But still, it's a possibility. Okay. So you can pick which do you think is the most important. But personally, as someone who doesn't work for an airline who might be interested, I think the consumer would be interested for planning purposes. And you can say planning purposes as I want to book a flight here or I don't. Or you can say when they land, that type of thing. Based on your previous work with dot plots, which I hope you did in 7th and 8th grade, but maybe you didn't. And if you didn't, this should be the first time and you're interpreting, right? Would you describe this graph as representing a symmetric or skewed? So this is the first that we're really using those two terms. And I'll give you the basics on those terms. Symmetric is the bump is in the middle and you got an equal amount on each end. Skewed is the bump is on one side or the other. So your bump in data is on one side or the other. There is clearly a bump in data on this side. This is going to sound really weird, okay? But the way we describe this is skewed right because the tail of my data is to the right. So wherever the tail of my data is, the kind of dribble off, that's the direction we call this skewed. So this is skewed right to the right-hand side. That's where the bump in the data goes to. Oh, excuse me, the bump in the data is on the left. The tail of the data is on the right. So we use the direction based on the tail. Okay, we use the direction based on the tail. That's dot plots. Just looking at them and interpreting. Histograms. So this is a histogram of ages for people in the country of Kenya in 2010. Okay? Again, I want you to stop. I want you to pause. I want you to look at the histogram. I want you to think about what it's telling you. Okay? You might now have words like skew and symmetric in your head. Looking at this. Okay? But pause, think about it, come back. Okay? Hopefully you're back. What do you think this graph is telling you about the population of Kenya? My eye is so drawn over here where the majority of the bars is. The height of the bars is higher over here. And these ages are 0 to 4 and 5 to 9 and 10 to 14 and 15 to 19, right? That's what these ages are. And look at these percents, around 17%, around 14.5%, around 11%, around 10%. Okay, well, let's add that real quick, right? If we add that real quick, let's say 17 plus 14, right? 21%, 31%. Hello. Wait, that's almost a third right there. Add one more, 11 to that. You're now at 42%. 52% of the population is under 20 years old. What do you think this graph is trying to tell us about the population of people in the country of Kenya in 2010? That they're mostly young people. More than 50% of the population in Kenya in 2010 was under 20 years old. Why might we want to study this? Well, we might want to know why that's the case. Why is so much of the population of that country young? Right? Is it a disease? Is it a famine? Is it clean water needed? Is it something along those lines? Is it a war that's occurring? What is it that is happening in Kenya in 2010 that's causing this? Okay. So, why might we want to study this data? To find out why Kenya's population, sorry, I write my K's so fast they don't look capitalized when they are, is so young. Why don't they get to age? You'll see the US's in comparison later, and it will be kind of shocking. And of course, this is very skewed. And again, it's skewed right because the tail of the data is to the right. Okay, so this is skewed right because that's where the drop off is. The majority of the data is right here. Okay, so since the majority of the data is right here, this is considered the tail or the drop off. So this is the direction of the tail. That's the direction we skew. That's what we call it. Okay, last type. 30 students from River City High School were asked how many pets they owned. The following box plot was prepared. Now, before you have your minute to analyze, right? Before you take your minute to analyze, let me remind you, because this might be the first time you're looking at a box plot, let me remind you that a box plot divides your data into quarters. So it divides it into 1/4 of the data here, 1/4 of the data here, 1/4 of the data here, 1/4 of the data here. Anything like this is what we call an outlier, and we will learn more about that in lesson 6. We'll learn how to calculate that in lesson 6. But the basics of an outlier is it's data that doesn't fit with the rest. Okay, there's an actual calculation to that, and we'll figure it out. But for now, I want you to go in knowing that each of these sections of a box plot is 25% of the data. Okay, so pause it, take a minute, analyze what you're looking at, and then we'll answer our questions. Hopefully you're back. And here we go. What does the box plot tell us about the number of pets owned by the 30 students in River City High School? Well, if each section of the box plot, there we go, let's use words, is 25%, then 50% of the data is between here and here, right? So half of the students own between 1 and 5 pets. What's half of 30, by the way? 15. Oops, spell between, right? I shouldn't say own. They live with you. You don't own them. They live with you. Your family, your pets. Why might understanding the data behind this graph be important? Well, let's say you're a budding entrepreneur in your school and you were thinking of having some sort of maybe pet food type of business on the side. You might want to know what kind of pets and how many people have them. And considering 50% of your classmates, these 30 classmates anyway, have 1 to 5 pets, you might be able to interpret, oh, a lot of people have pets. Maybe I can capitalize on that. So we want to know who owns pets and how many do they own? And again, I use own very loosely. My personal cats, obviously, family members who happen to live with us and be a different species. Clearly, we don't own them. Right? Right. But that's how we do this. That's how we do the interpreting. So this is a good time to, look at your homework and see, oh, okay, this is what I'm asked for here. It's very similar to this. It's going to be sentences. I want sentences describing what's going on here. What are you interpreting? Re-listen to this, re-watch sections of this, because I know box plots might be on the newer side. We're going to learn how to create these ourselves, but we need to understand what they're saying before we do any of that creating. And as we create, we will continue to understand what is this data I'm looking at? What are these visual things that I'm learning by looking at these graphs? That's what's wonderful about graphs with data is you are quickly visually taking in a lot of information about what's going on with your data. Okay, so it's just a little bit nicer at times than just straight looking at the numbers. Okay, all right, guys, this has been Chapter 2, Lesson 1 notes, and I shall see you again very soon for Chapter 2, Lesson 2. All right, have a one. Oh, don't forget graphing calculator. Graphing calculator for Chapter 2, Lesson 2. Have it ready to go, either physically or on your computer like mine is right here. Okay, and again, there's the free Chromebook app that is in all of my Google slideshows that you can very easily look to. Mine is a little bit different because I don't use a Chromebook. So this is not the look of that calculator, but it will be very similar. Okay? All right, guys. Have a wonderful day. See you soon.